Hello, this is Tyler Beamer at Haywood Community College. This is an instructional math video for Math 152 in regards to frequency distributions. I'm going to work through this particular problem in the Chapter 2, Section 2 homework, problem number 8. I'm using the notes that are on Moodle for Chapter 2, Section 2 as kind of my guide. Alright, so this particular problem refers us to a data set of 30 screws, and their screw links are recorded. And it wants us to begin with the lower class limit of 3.720 inches and use the class width of 0.010 inches. So we're creating the classes, and then we will use the actual data and find the frequency for each class. So let's create the classes first, and just recall that class width is the difference between the two consecutive lower class limits. So if the class width is 0.010, I should be able to take the lower class limit of the first class and add 0.010 to it, and that should give me the lower class limit for the next class. So you can continue to do that, I guess, and you get the lower class limits for each class if you'd like. And you can kind of get an idea of the pattern here. You're basically increasing by 1/100ths each time. Okay. And if it helps to put the 0 in here, you can do that. I'm just going to do that since that's how it was given for the first class. Okay. And so then we want to come up with the upper class boundary. So essentially, since I have 3 decimal places given to me in the problem as the lower class limit for the first class, then I want to use 3 decimal places in the upper class limit, and I want to get as close as I can to the lower class limit of the next class. So in this particular case, that would be 3.729. Right? That's as close as I can get to 3.730 using 3 decimal places. And so I continue that trend for the other classes so that I can then create the upper class limits. So 3.739 is pretty as close as I can get using 3 decimal places to 3.740. So as close as I can get to 3.750 using 3 decimal places would be 3.749. And I continue that trend. If I added another class width to the last class, you know, the next class lower class limit. Let me just go ahead and show you this on the. So if I just keep adding this. Alright, that's the last class, and then of course if I add one more, alright, that would be the class that would go here, right, that we're not showing, but that might be helpful, alright, for you to then come up with this upper class limit for that last class. So that's just kind of a little helpful hint there if you need to do that. Okay. So now that we've got our classes, we want to open the data set. Okay. And so notice that these 30 screw links are not given in any kind of particular order. And so having them in an order would obviously be helpful so that I can then come up with the frequencies of each classes. Okay. So what I'm going to do is click on this icon and open this data in Excel. And what that does is it basically just takes that data table from my stat lab and it puts it into a Excel spreadsheet. And then if I highlight the data and then go over here to sort and filter, and I can put the data in order from smallest to largest. And so that's helpful, right? That allows me to essentially put the data in order so that it makes it easier for me to determine how many data points belong to each class. Okay, so if I look at my data set, right, the lowest value I have is 3.721. So any data point that is between 3.720 and 3.729 belong in that first class. So this data point, so 1, 2, 3, and once I get to here, right, everything else is above 3.729, right? So basically this has a frequency of 3. Okay, so this is the first class. Okay, so then I can start at 3.733, that's the next class. And those go all the way up to 3.739. So that would be this data point. So 1, 2, 3. So another 3 data points. Okay. And then when I get to here, I'm at the next class. So that goes from 3.740 to 3.749. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. Alright, and so I'm just really just moving down this ordered list, putting the number of data points that belong in each class. And so once I get to this data point, right, that moved me up to the next class. Okay, so that goes to 3.759. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 data points in that particular class. Okay, and then this is the last data point, which would belong in the last class. So that's a helpful hint, using Excel here to essentially sort the data. Then you can just kind of move through and see how many data points belong in each class and kind of do it manually. There are some specific other tools and features on Excel that you could use to sort and kind of put things in data classes, but that'll be a little bit more involved and not necessarily something that you have to do to solve this particular problem. And so the checking mechanism here would be to add up all of the frequencies for these classes, and so let's do that now. So if I add up the frequencies of all of these classes. Right, I should get the total number of screws that were in the data set, 30, and I do. And so that's kind of the checking mechanism there to make sure that you didn't leave any data point out. And then you could check that answer. And then the next part says, does the frequency distribution appear to be consistent with the label? So the label says that the screws were supposed to be 3 3/4 inches, right? And so 3 3/4 inches in decimal would be 3.75. And so we do see that the majority of the screws are in this class that does include 3.75. Okay. However, we do have some screws that are below that class, and also one screw that's above it. So let's see what our answers are. No, because the class frequencies are not consistent. Yes, because the frequencies are greatest and the class is closest to the label size. Excuse me. Yes, because the screw links are no more than 0.03 inches off the labeled size. Okay, so no more than 0.03 inches, right, would basically put us between 3.78 and 3.72. Okay. And that is the case. All of our data points are within the margin of error of 0.03. So I think it's either B or C. Let's try C here. And that's not the case. So let's check B. So even though C is accurate, I mean, all of the screws do lie between 3.72 and 3.78, which is the margin of error that's given here. I guess B is actually the better answer, because the majority of the screws are closest to the 3.75. I mean, 14 screws are in that 3.75 class, so I guess that's probably the better answer. But you know, multiple choice, you can use your critical thinking skills to narrow it down to a couple of answer choices and then choose the one that is the best fit. So alright, hopefully you found this video helpful. If you have any questions, as always, please email those to me, and have a great day.